now let's bring back that solar concentrator and ask that question, why does it appear orange? Probably another question you may have is, why is this thing so beat up? Well, let's bring John back in here. John, remote mic, can you explain why this panel is so beat up?
Yes, you can see, Steve, that even though it is beat up, it's still fluorescing quite well, and it's very efficient. So if you compare that to, say, a normal solar panel, if you were to beat it up that way, it would not function. It would not continue to function.
Okay, makes sense. Okay.
And so you have Northwest roots, Pacific Northwest roots as well?
I do. I grew up on Bainbridge Island, which is close to Seattle, and then went to college in Oregon and came back to Washington about 10 years later.
Excellent, excellent. So can you tell us a bit about your research that's going on up at Western involving clean and renewable energy?
Yeah, my research is in the field of heterogeneous catalysis, and we make solid phase catalysts, and in particular, they're useful for removing impurities out of crude oil and also for upgrading biomass to biofuels.
Excellent. So you're involved in both clean energy and renewable energy.
That's right. I've been in clean energy for over 25 years now, and the renewable energy just for about the last year or so.
Okay. Great. Yeah, so while we're on this topic of energy and crude oil and whatnot, we have a plot of Hubbert's curve that we'd like to show to the audience. And so can you explain this plot a little bit to the viewers?
Yeah, Hubbert's curve is a plot of crude oil production as a function of time. And as you can see from the curves, there are curves for different countries and then for world oil production, that the production of crude oil goes up as a function of time starting from the early 1900s and then peaks at some particular year, and then production starts declining. In the particular case of the United States, we reached our peak production in about 1970, and Hubbert, who was a geophysicist for Shell, accurately predicted that that's when crude oil production would reach its peak in the United States. Well, it's still unknown when the peak of world crude oil production is going to be reached, or if it already has, but if it hasn't happened in the last couple of years, it's probably going to happen in the next 10 years or so. And after that, crude oil production is going to be decreasing, and so we really need to be looking at what are going to be the future renewable fuels.
We'd like to focus on sort of the local population, so how does this really affect the local populace?
Well, one of the things that we're already seeing is that oil prices are high. You can remember for the longest time, crude oil prices were typically $20 a barrel. And then over the past 2 or 3 years, they've cycled up and down, reaching as high as $140 a barrel. And now they're down about $85 a barrel, so still very high. And so we see that in higher fuel prices. The other thing to think about is that the oil we're getting out of the ground now is what's often referred to as dirty oil. You take all the easy oil first, that's all gone, and so now we're left with dirty oil or unconventional oil from places like the Canadian oil sands. They're very rich in impurities, and we need to remove those impurities so that we can burn the fuel cleanly and efficiently.
All right, what are you working on here?
Getting ready to test one of our catalysts to see if it's going to be useful to produce biofuels.
Oh, biofuels.
Yeah.
So renewable type energy?
Yeah, renewable fuels.
Excellent.
So we test the catalyst. We load the catalyst into the tube right here, and then we inject a bio oil into the system where it mixes with some hydrogen. The hydrogen gas carries it to the catalyst where it reacts and removes the oxygen. And then the fuel that we just made condenses down here where we collect it and then analyze it to see if how much oxygen we've removed from it.
Yeah, that sounds fantastic.